A very good morning to the seniors and my colleagues. Today my paper is on concept paper on using 3D modeling to learn surgeries. I don't have any financial disclosure. So COVID had disrupted the physical learning process and the computer simulations has been a part of the learning process. What we tried to have a 3D modeled cornea over which we can simulate the surgical learnings. Basically the reason being that conventional modeling is costly, copyrighted and it's scarce. So the objective is to make a feasible model for anatomical learning, reproducible model, tissue properties and disease modeling if possible we will incorporate, and surgical step discussion if possible. What is the crux of this paper is a concept paper. So we sort of concentrated on how to, the journey, what is the journey of this 3D modeling of this cornea. So we started with, one second. We started with a base plate. We started with a base plate and continued with the formation of a semisphere over the circular movement along this axis. And actually this is done over a software. And on the spherical cornea, so the sphere is constructed and the elevation points are regular. So first we constructed a spherical cornea. The cornea extrapolated from the spherical cross sections. All the semicircles are same in size. 3D rendered as 1/4 slice rotated around the central Z axis. This is the Z axis. And these are done on the paint software in iPad. And then the oblate, so there are two curvatures in cornea. One is primary curvature, this one, and there is another, this one is the secondary curvature. So when we construct one primary curvature over one base plate and one secondary curvature and over another parallel base plate, this is the primary base plate, this is the secondary base plate, we will get two curvatures. And if we reduce this curvature, if we remove this curvature, we will get a blending at the curvature points. So these are the 3D models rendered. Three concentric circles on two axes. And the primary 2D drawing is that the first curvature on the bluish curvature, the first curvature would be on the 5mm circle and the second curvature would be on the 7mm circle. There will be blend in the junction. This is the blend. And there can be two models, cylinder on cylinder or sphere on cylinder. So this is a cylinder on cylinder model. So we first construct the circles, then we extrapolate them as, extrude them as cylinders, and we try to blend the final held up margins, I mean the free margins, we are trying to mold them as a circle or sphere. And this is sphere on cylinder, so the inside is a cylinder, inside is a sphere over which we have constructed a cylinder. Now the cylinder can be extruded as the sphere goes on. We can change the diameter of both the sphere and the cylinder. So the sphere will, the sphere, as many spheres we can include, as many cylinders we can include, they will actually represent different layers of the cornea. Layers after 2D imaging, so these are the layers, they are the three simple square lines. This is as if a sandwich. Now if we can mold this sandwich in a circular fashion, so we can have a base as endothelium and the epithelium. And we can have different tissue properties along the cross sections of these base plates. So what are the materials and methods of this study? This is a very short study. 3D model of the cornea have been created, shared among 9 PGTs and 4 seniors, at least 3 years of experience. So 10 hours to use and learn. Most of the simulations use this hour kind of a way to understand what is actually happening with the simulations. Post-learning multiple response method was used to grade. This is a very crude study, and post-learning method was used, proxy method. We have used a proxy method to, basically it's a social research method, but we cannot use any case control or a better cohort study because our sample size is small and our 3D model is just in the journey to perfection. So it is semi-quantitative and a multiple regression analysis was made. Parameters were acceptance, simulation, reproduction, and shareability. Now the results, acceptance is quite high among the five gave around 6 of score. We used ANOVA. In the simulation, there's a finding that cumulative frequency shows acceptance takes time. So basically we tend to favor what we have learning throughout the process of our surgical learning, right? In our PG days, in our UG days, we use 2D images, not 3D images. So it takes time. The cumulative frequency shows that it takes time to accept this thing. And it's a reproducible learning because you tend to see the same images or a modified version of the 3D images again and again and again. So it's a reproducible learning. And it definitely is shareable. Across the platforms, it's shareable. So models are accepted over hours. Pilot proves that prospective terms for the same. And software needs upgradation on dynamic modeling. This is static modeling. What we have done is a static modeling. We can do it with a dynamic modeling. Like we wanted them to use different corneal sections over the corneal model. We can have a dynamic modeling where the cornea changes as we made the sections. Layers the microscopic properties can be introduced in the layers, like lower endothelial count, like previously traumatic cornea, kind of that. We can adhesion properties can be incorporated. Tissue elasticity coefficient can be incorporated, but it requires calibration. Printing on nozzle technique can be considered, and bioprint can be considered. So 3D modeling on cornea is quite effective. That would be my conclusion. Versions to be bettered on this pilot, but it is quite a new arena and a bright zone to improve for the qualitative learning and assistive learning. These are my bibliography. Thank you so much.
What is the material used for making these 3D corneas?
Sir, these are actually basic models, 3D models. We extrapolated those models as images and modifiable images, PAR. The file can be PAR, can be IPO, and those can be shared over a particular software.
No, so basically the practice is done actually on images, or actually you're producing printouts?
No, sir, printout hasn't yet been done. We have tried.
What is the material used for that
printout?
Yeah.
Sir, PDMS.
What is that?
Polydimethyl xyloxane. It has 3 grades, 1, 2, 3. We can have bioprints too, the cellular bioprints over the PDMS also. And as well as silicon xyloxane itself is available as a 3D print material.
So once the cornea print comes out, how do you practice on that? I mean, do you have an eyeball? Where do you fix it, and how do you practice? How does the student?
Sir, it's actually part of a whole project. So we have to form a frame for any biotissue holding. So we have some marketed frames for biotissue holding, like they hold a part of the cornea, part of the sclera, part of the lens. So we can try drug testing. So we will be using those marketed ones, and if time permits, we can print them too.
And even surgery can be practiced on that if you fix it in the frame.
Exactly.
It gives you the same tissue field that you get.
Yes, and the tissue field would be changing depending on the adhesive properties and the printing material we are using. So.
Very nice, thank you.
Okay, you can use an artificial anterior chamber which you use and put this cornea on top, which should be easy. Already it is available.
Yes.
You don't need to get a frame or anything.
Yeah. Thank you, sir.
And the last is Karishma Goel.
Karishma.
Yeah, please. Single piece IOL for sutureless scleral fixation.